every points on the well path should have the first characteristics or first feature is called inclination angle. So if I want to know the inclination angle of this point, we'll make a vertical line and then measure the deviating angle or angle from the deviating line to the vertical line. This is called inclination angle. Another features is called measure depths and true vertical depths. There is two depths in directional drilling. In normal drilling or conventional drilling, there is only true vertical depths. True vertical depths, it is the vertical distance from the surface location to the target point or measured point I wish to have the depth of it. So in true vertical, while in directional drilling, I deviated from the vertical. I deviated from the vertical and building angle. When I deviated from the vertical and the building angle, I have another depth which is called measure depth. So if in this point, the measure depth will be all of these points from the surface and on the well path. This is the deviated well. This is the deviated depth. While the vertical depth, if I stop in this point, this is the measure depth over the path of the well. True vertical depth is the depth from the vertical distance from here to the rig or the surface location. This is called true vertical depth. So the measure depth, it is the measure depth along the well path or well bore of the well. While the true vertical depth, it is the vertical distance. It is the vertical distance from the surface location to the survey point or the point I take it as a calculation point or reference point. The last thing is kickoff point. The kickoff point, it is easy. The kick point is the point at which the deviating will start. Before the kickoff point, the angle is 0. After the kickoff point, the angle will increase and the building until I reach the building angle and the target angle. We talked about two build up rate and drop off rate. We called building up rate as if I increase the angle or a changing of the inclination per 100 foot. If the what's meaning of building up rate? Building up rate or abbreviations or called it BUR. It is the rate where I increase the angle per 100 foot. So if the at 0 degree the build up rate is 3 degree per 100 feet. So after 100 feet the angle increased to 3 degree. As if the depth now is 200 feet, the angle will be increased another 3 degree. So the angle will be 6. Then the angle will increase by 3 degree per 100 feet as I reach the depth. Another rate is called drop off rate. When then I building the angle and I reach the target angle, say it's 40, then I hold for the 40. If the target is here, so I need to drop off to decrease the angle. To decrease the angle from the maximum angle I reach, that's 40, I want to return vertically to 0 degree. It's called drop off rate, which is the decreasing of inclination per 100 feet. It is the opposite of building. There is two options. There is 3 options for direction well profile. Building, it is the increasing of the angle. Holding, it is keep the angle constant. The third thing, it is dropping, which is decreasing the angle from the maximum angle to vertical angle reaching also to 0. It depends also on the well plan and well profile. So we have a lot. Of direction well profiles, but the most common and the most significant profile is called First type is called, it's composed from two sections. We called it G type or type 1 hole or S-shape hole. Type 1 hole is we start vertically to drill vertically. Then from the kickoff point, we make a building section to reach the target section. Say we reach 330 degree, then we will hold 30 degree until we reach the target. The first section is called building section. The second section is called tangent section. This is type 1. It composed only from two sections, building section and tangent section. The building section increase the angle until I reach the target angle 30, 40 according to the plan, then keep the angle constant until I reach the target. The second type is called type 2 or called S shape because it's like S letter in English language. It starts with the vertical, then with the building angle, with increasing the angle, the same as type 1, then tangent angle, keeping the angle. The more or the addition than type 1 is dropping the angle, which means decreasing the angle and return vertically. This is called type 2 or S shape because it's like S letter. Type 3, it's called deep kickoff point or horizontal type, which will be composed only from building section. As I mentioned, the horizontal drilling means the angle will be 90 degree. So will composed only from building from 0 until I reach 90 degree to be horizontal. There is some explanation, more explanation. This is the one in this picture. It is the ordinary one, which is the vertical straight well, which is the vertical well. There is not directional well. S shape, as I mentioned before, will have in S shape 3 section. We'll start section, then kickoff point. We called it building section. Then we holding the angle. In this section, we called it tangent section. Then we decrease the angle. We called it drop off section. This is the S shape type. Slanted well or G type well. It is the simple type of directional well profile. It's composed only from two sections. It is the build up section increasing the angle and keep the angle constant, which is the tangent section. Horizontal wells, it can be composed from according to the design, can be composed from one building section, can be composed from building section, tangent section, and the second build until I reach the depth. So in horizontal drilling, we need to increase the angle from 0 to 90 degree. This is the huge angle, and the pipe cannot be simple to deviated and to have many loads. So the deviated or increasing the angle, may I make it through one section, or I make building section like this one, then will cause tangent section, then will I build again to make the hole more smoothly to reach the target. So let's start with type 1. Type 1 will be focused in the type 1. Type 1 is called G shape, or it's called build and hold. The type in type 1, we start to drill vertically. Then when I reach the kickoff point, I plan the kickoff point, and we will know in the second day and third day how to select the kickoff point, when to start to deviate the well. It is depending mainly according to the formation, according to the rock types, according to the circumstances in the hole that I can start to deviate the well. Then when I reach the kickoff point, it is the point when the angle start to increase, will increase the angle until I reach the maximum angle I want to reach it, say it 40 or 45 according to the plan. Then I will increase the angle from 0 to 45. This is this point is called end of build up section, as it shown in the previous slides. It's called end of build up section. It's called by abbreviations EOB. Then I want to hold the angle at 40 or 45 according to the plan until I reach the target. It is called in this called tangent section. So the type 1 is made up of kickoff point, build up section, tangent section. This is type 1. This is type 2. It's called S shape. We have two types of S shape. We have first type. It's composed. I drill the well vertically until I reach the kickoff point. Then I will increase the inclination from 0 until I reach the maximum building point I want as according to the plan. Then I will holding the angle until specific point, which is this is called tangent section. So as I mentioned, as we see in the type 1, there is kickoff point, build up section, tangent section. What is the new in S shape section or type 2? We want to drop off the section. We want the target is here. I cannot continue with the tangent section. I cannot keep the angle because the target below the well path. So I will decrease the angle. We call the decreasing of angle is drop off section. So if I reach here 40, I want to dropping or decreasing the angle from 40 say to 20, for example. So I will start to dropping the section by dropping off rate. The drop off rate, as we said before, there is building up rate and drop off rate. The drop off rate, it is the amount of changing in inclination per 100 foot. So for example, if the drop off rate 2 degree per 100 foot, so if the angle is here 40, after 100 foot will be 38, which means it decreased by 2 degree. Then more as I drilled 100 foot. So I drop the angle to until reach the end of drop off section according to the plan. Whereas from here, if I start here 40, then according to the plan, for example, I should end at 20. Then I will hold the angle or keep the angle constant until reach the target. So this is type 2. It's S shape. It's more complicated and it takes a lot of effort while executing in the field and happen more difficult condition, but it is required for specific reasons according to the geological plan, according to the target depth, according to abstractions in the hole. Sometimes I need to make S shape. Another type from S shape, but it's called modified S shape. What is the difference between S shape and modified S shape? The modified S shape start with the same thing, start with the vertical section until I reach the kickoff point. Before the kickoff point, the angle is 0. After the kickoff point, the angle start to increase. The angle start to increase until I reach the end of build-up section with the target angle. Then I will keep the angle constant until I reach the end of or the start of drop section. When I reach the start of drop off section, I decrease the inclination, say from 50 to here, not from say here the tangent angle is 40. Here I should return vertically. What is meaning returning vertically? Vertical means the angle is 0. So I should return from the maximum inclination I reach, the maximum inclination I reach to return to 0. So this section I return from at the start of drop from the angle, maximum angle, say any angle 50, 60 to 0 at the end of drop of section. Then I will keep the angle 0 until I reach the target. So this is the difference between S shape, ordinary S shape, and modified S shape. The difference in the S shape have building up section, tangent section, dropping section, hold section. It is have the same sections here. If we see this plan, have also kickoff point, have building section, have tangent section, have dropping section, have holding section. So it is similar, but is the difference in the drop of section. When I drop the angle, I drop from the maximum inclination. For example, if there is the angle here is 20, I return to 0. But here, I don't return to 0. I return to another angle, say from here 40 to 20, 30 to 10, according to the plan. So if I return to 0, I call this shape is modified S shape. If I don't return to 0, I call that type 2 S shape. The last type is called deep kick-off point or deep kick-off trajectory. The deep of point or trajectory is composed of simply of two sections. The first section I will drill vertically. Then I will start to kick off the point, but where I can start the kick off point deeply. Yeah, this is the section maybe at 6,000 feet, 10,000 feet. From this name, we called it deep kick off point because in some formation, I cannot make the kick off point directly from the shallow depths due to some abstractions we will discuss in more details in the second day. These abstractions make the kick-off point at deep depth. So, and when I reach the kick-off point, I will start to building the angle. So, if I start to building the angle and I reach 90 degree, I called it horizontal drilling. If I not reach the horizontal drilling, I keep it as deep kick-off point. Sometimes there is another type is called continuous build. As from this, as I see this line, this line start with continuous build. There is no tangent section. There is no holding section. There is no dropping off section. Only one section. Horizontal drilling. Horizontal drilling, I can make horizontal wells. What is horizontal well? The horizontal well, it is directional well. Basically, it is directional well, ordinary well, but it have the inclination angle at 90 degree. So I can make horizontal angle with any types of profile. Can make it with type 1. Can I make it with type 2 or type 3 as a modified S shape with type 1 according to the formation and design situation of your field. Say, for example, for this one, we make kick-off point, then we make a building section, and then holding the angle, then increasing the angle at the last target. So when I reach here, may I reach here to 70, 80 degree, then I keep the degree tangent location, then I deviate it again at the target. Or it can be cause a deep kickoff point, as well I drill vertically until I reaching the kickoff point, then I will continuous build until I reach from 0 to 90 degree. Okay, so this is the figure we use in design of the well. For example, this is the bore hole, this is the hole, and this is the vertical line. It is imaginary line. If I want to measure the angle, what can I do? For measuring the angle, I will take a vertical line. This is the vertical line, imaginary vertical line, and this is the actual well path. So the inclination angle will be the angle between the vertical line and the deviating line or deviating well bore. Another thing from the inclination angle, it is the azimuth. What is the meaning of azimuth? Azimuth, it is the direction of borehole. So I can drill the well from this direction, or can drill this well from this direction, or can well the well from this direction. What is the controlling point? It is the target. Each target have azimuth. As we saw in the previous slides, the azimuth, we defined it. It is the angle from the north direction. This is the north direction here. It is the angle from the north direction clockwise. This is in clockwise direction, not in this direction. So the azimuth measured from the north direction clockwise. So every points on the well path will have inclination, will have azimuth, will have measure depth and true vertical depth. And so the vocabulary of directional drilling will be as shown in the previous slides. We'll summarize on our first the kickoff point. We'll summarize all what we have today. Kickoff point, depth of point. It is the starting of building or dropping the angle. It is the start of building angle, which is kickoff point. Ending of build up section. It is the point of ending the inclination. We're increasing the inclination from say 0 to reaching 30. The tangent section, as we saw in this slides, the tangent section, we keep the angle constant until we reach another drop of point. We sometimes called kickoff point too, but we don't usually called it kickoff point. We call it drop of point or start of drop, then reach the end of drop of section, then reach the tangent section. All of this we discussed, but there is another new definitions we need to know. It is called dog leg. What is meaning of dog leg? From the name, it is like the dog leg. It is indicate the rate of build up per 100 feet. The dog leg is used for determining the maximum or mechanical strength of the pipe. Sometimes the mechanical strength of pipe may be failure if the dog leg increase largely. So we should measure the dog leg severity at each 100 feet to determine from the location what is the maximum depth we can reach, and we control and correct the angle. We have finished the first sections of this day about the introduction.
Day 1.
Yes.
So let's go towards the Q&A for the day one. So guys, if you have any question, you can just post in the chat box. So first question, based on what factor we should choose the KOP? Is there any criteria required for choosing KOP?
What is the software? What is the software to design all parameters or software used to define the trajectory, right? Okay, the software we will do in the last day we'll do well planning. There is we will know the equations that we use to determine all parameters and how these parameters are used to draw, and then we'll use programming excels to use the softwares to draw the well path, to do cross plan view, to do all the parameters I mentioned. Lot like well view, side view, docs, well arced. All of these software, according to the company, use different versions of software, but all softwares will have the same equations. All of software use, we'll discuss it in the last day, in day 3. It's called minimum curvature radius. This is minimum curvature radius. It is one of the most common using equations in all software to do design of all parameters. We know the basics idea of all these software. We will know how this software will do the calculation, and we will use these equations with the real field data for directional wells to determine the design parameter for the directional wells. Another questions, please can you explain vertical section again? We'll explain it. Oh, okay. Those days, Webstock is still applied to make kickoff point. No, Webstock, your questions will be answered tomorrow, but I will answer you a small small answer. Webstock, it is used in the old way of deviating the well, but now no one use Webstock. There is a lot of new technology, new mud motors, new rotary steerable system. Another tool, another significant tool. It is used nowadays that save a lot of time, save a lot of money, make more accuracy for the whole. So Webstock, it is not no longer used. I have doubt about the casing, about the inclination angle. How do we account the pressure drop? Okay, you talk about different things: casing, inclination angle. We don't make a casing. We drill first, then make a casing. Then I drill from inside the casing. I don't drill inside the casing. I drill in the open hole. Then I install the casing. Then when I start to drill again, I don't drill inside the casing. I drill outside the casing. And how do account pressure drops? The pressure drops is determined regularly, like the vertical drilling. It is determined from the true vertical depth. It is determined from the true vertical depth from the ordinary calculation. If you know the hydrostatic pressure, we multiply 0.252 density of the drilling fluid by the true vertical depth. Then I know the pressure drop across the system. I know the hydrostatic pressure, all of this. One thing is missing, net direction. Not missing. What is net direction? The direction of the hole is determining by azimuth. Azimuth, it is measurable. It can be measured by azimuth tools, by surveying tools, The most common surveying tool, it is called Azimuth. Azimuth is used to determine. Azimuth is used to know the direction well. It is give you the net direction. Where is the hole in the right or the left or up or down? According to the azimuth, you will know the net direction. What is the difference? Another questions. What is the difference between horizontal displacement and vertical section? This is God's question. Vertical, if we see this plot, horizontal displacement means it is the distance between the vertical, it is the horizontal distance between the vertical location. Say this is the vertical location of the surface rig, and this is the target location. The horizontal distance between them, we called it horizontal displacement. Okay, what is the vertical section? The vertical section, it is the projection of the horizontal displacement on a vertical plane. So if this is the horizontal displacement, the projection on a vertical plane, on the vertical line, we called it vertical section. Another question. Based on what factor we should choose the kick-off point? Is there any criteria required for choosing kick-off point? This is great questions, and this will answer tomorrow on how to determine the kick-off point. The kick-off point is determining according the kick-off point is determining according to the formation types, according to the geological of the region. So will be explained more in the second day. Questions for this course: are we going to use geological reservoir software for well planning? In directional drilling, we don't need to know the reservoir anymore. We know only from the reservoir, we need to know the location of the reservoir. When we make planning, when make directional well planning, we take from the reservoir engineer the location of reservoir, at which depth the reservoir should be penetrated, what is the recommendation of reservoir engineer of the reservoir according to the coordinates x, y. That's it from the reservoir. Also, we can take recommendation if the reservoir needed to be directional, in which types we need, or if we need to do horizontal wells, as in horizontal wells, it's increased the production. And if the reservoir, beneath the reservoir, there is any water that can make the oil production difficult and make the water to move to the hole and produce water, all of this we know from the reservoir engineer. But from the design point of view, we don't need to know any reservoiring feature. Another questions. Please, can you explain dogleg in details? The dogleg, it is the change in inclination and change in azimuth per 100 feet. How it measured? It measured by specific formula. This is formula. We will share it in design section. Another questions from Sarah. Actually, we still use Webstock in my country. We use Webstock when kick-off point from the casing. Okay, this is great point of view. Webstock, I don't mean Webstock cannot be used or not used over the wallet, but the Webstock can be used for specific application, only for starting. For example, if I want to drill inside the casing, and making a casing window, this is we will use Webstock for kicking for this purpose. But there is a lot of tools nowadays, a lot of companies use a lot of techniques that we don't need to make kickoff point by using web stock, but it in the casing I think it web stock it is used for only casing application. But the first questions was about the it is web stock used in kickoff point in general. Another question from Ariel: which tool is the most recommended to make the curve? The tools we'll discuss it in more details tomorrow. There is a lot of tools. There is web stock. There is jet bed. There is mud motor. There is mud turbines. There is rotary steerable system. A lot of tools. The most recommended one or the most used one now is called RSS. What is RSS? It is rotary steerable system. It's have many advantages. It have many accuracy. We'll talk about in details tomorrow. Web stock we used at the window cut in the casing. Yes, I mentioned it for Sarah, as it said it's used in her country for casing window. How we build the angle during window cut? This is questions how we build the angle during window cut. Actually, for building angle during the window cut, we use, for example, if we use web stock, it will have a specific angle only for kicking off the wheel or for start of deviating the wheel. After that, I will use ordinary tools or use mud motor, rotary steerable system according to the deflection tool that is available. Another question: what are all parameters checked at the time of survey after stand? Okay, you mean stand? Okay, stand or joint stand. It is 90 feet or according to the pipe you drill. The each parameters after each stand, as I mentioned, we will check by if you visit the field, you will have MWD and directional units. MWD, which may stand for measurement while drilling, and directional drilling units, DD. It is after each stand, it's use the system and send mud pulses through a specific system to measure the inclination angle, to measure the azimuth angle, to measure the measure depth and true vertical depth. And another, this data is collected at the surveying tools, and we will use it to keep the well on plan. So we will plan first, then we will monitor each execution of drilling with surveying and know all parameters. Another questions from say we drill first vertically, then we take angle. How we insert the casing in inclined section? I think it is difficult insert the inclined casing in vertical section. This is great questions, and this is another problem or another topics can be discussed as a whole. But the casing can be set up in inclined section because we make the hole smooth. As I mentioned, the dogleg severity is the change in inclination and azimuth per 100 feet. We keep it smoothly for easily inserting the casing. So it is good questions. It may make a difficult, but it is not make a great difficult. It can be installed without any difficulty if the path of the hole is smooth and not change the angle greatly. If, for example, if we make the building upright to 2 degree, 3 degree, it is will be easy. But if we make a drop of building upright high, it will make the casing difficult and may stuck in the hole. What will do we do if any problem in directional? This is general questions. I can't specify what is the problem. Can many problems can happen during the directional. Some of the casing, some relating to the hole cleaning of the hole. One of the major problems of directional drilling is hole cleaning. Hole cleaning will be very difficult during the high angle inclination, and this